Hello students, let's discuss about the relational algebra equivalences, which is basically the next topic of the relational optimization criteria, that is the optimization of the queries that we are discussing, the way optimizer works, right? Basically, it is the nested queries are divided into some blocks, right? And blocks of the select, project and the join operation. Okay, so those nested queries are basically first converted. Those blocks are first converted to relational algebra expressions, right? In the relational algebra expression, for the relational operations, you find some equivalent way of depicting those operations. Okay, so those topics will be discussed here, which are the equivalent operations. That is the way the equivalence can be judged in terms of the relational operations. So, as you know, that is the relations, that is the blocks in the relations are nothing but actually the from, where and the select clause parts, right? Select clause gives you the projection, the where clause gives you the selection operations, okay, and the from clause gives you the cross product of the relations that are mentioned in the from clause, okay. Now, the optimizer can choose to evaluate any of the equivalent expression and still obtain the same result. So when we have the operations mentioned in a way, we can have the equivalent alternatives, and optimizer can choose any of those equivalent operations to actually get the same result for the output. Okay, so let's look one by one. That is the selection. Okay, in the selection, that means in the select clause. Okay, that is where we select the tuples depending on conditions. That is in the where clause basically. Okay, so in this selections which are actually mentioned in the where clause, as we discussed earlier, we have normally the conditions are expressed in the conjunctive nominal form. That is where the conjuncts are joined, right? Conjunctive terms are joined using conjuncts. So here C1, this C1 and C2 and that way up to Cn, this is the conjunctive nominal form on the relation R, okay, which is specified in the where clause, the selection operations. Now, when we apply together the entire conjunctive nominal form for selecting the tuples in the relation is the same as when you apply each of the terms separately on the relation. Suppose you first apply the conjunctive term, that is the relational operations specified as one term of the conjunctive nominal form, first on the relation R, and then on the result you apply the other term, then on the result you apply the other term. That way the entire set of terms you apply on the result set of another, that gives you the final result. That is the same if you apply as the conjunctive nominal form. Okay, so the cascading of the selections means the same thing. Okay, that is what this is actually. This is the way the cascading can be done for the conjunctive nominal form. So cascading of the selection are involved, so where we can have the equivalent representation that way. Another way of equivalence is commutative. Commutative, you know, that is first you do either one operation, then next go for another operation, or you change the order, you get the same result. Okay, so that is if you have a conjunctive term C1 and another conjunctive term C2, okay, the condition, that is the selection operations in the where clause, then if you apply the selection C2 on R first and then on the result if you apply C1, whatever result you get, you will get the same result if you apply C1 selection first and then apply C2 selection on that. Okay, if you change the order, the output remains the same. That is what the commutative means. So the commutative are actually the equivalent terms. Okay, so that is the selection condition. For projection operation, that is in the select clause of the query, the project operation. If you specify the project operation, suppose A1, okay, on the relation R, see that is being specified here. That is the project operation. This is projection. Project operation A1 on the relation R, Okay, that is equivalent to any of the term. Suppose the project operation means what? Only those attributes which are specified in the set A1 will be kept and rest will be eliminated, right? So if we have the multiple such project operations where the A1 is subset of AI is subset of AI plus 1, okay, that means here when we say project operation AN is actually superset of AN minus 1. Similarly, AN minus 1 superset of AN minus 2. That way it will go up to, like suppose project operation A2 is the superset of A1. Okay, so if you go on eliminating that, keeping those attributes which are there in AN first and then apply AN minus 1 on that, that way if you go on reducing, whatever the minimal set of attributes for the project operations you get in the result is the same which when you apply A1 directly. That is what it means. Okay, so this is what equivalence means in terms of projection. Okay, similarly we can have the equivalence defined for cross product and join. Cross product, as you know, is the relations which are defined in a from clause, and join means which are combined or joined by the join condition. Okay, so depending on those relations. Now here you can see the cross products that identified by the, suppose assuming that fields are identified by the name rather than the position. Okay, so these operations are basically commutative. If you have the cross product of two relations R and S, R cross S in the from clause is same as equivalent to S cross R. Okay, so that is you will get it is equivalent doesn't mean actually equality. Equivalence here it means that it will retrieve the same set of tuples. Okay, so here it is the R cross S is equivalent to S cross R. Okay, similarly when we have join is specified by this particular symbol. You see the join, when you have the join R join S is equivalent to S join R. Okay, so they are commutative. Similarly join and cross products are associative. Associative means when you have R cross S, suppose there are three relations, if you do S cross product T first and then do the cross product of R on that result of S cross T is the same as when you do the cross product of R and S and then take the cross product of T on the result set of R cross product S. Okay, you get the equivalent relations there. Similarly for associative is also applied for the join operations. That is, if you join S and T first and then apply the joining of R on the result of that S and T, the result that you get, resulting tuples that you get is actually the same, or you can say equivalent to the joining of R and S first, and then on the result of join of R and S, if you do the joining of T. Okay, so you get the equivalence there. So commutativity and the associativity of these relations which are mentioned in the from clause can be in any order. Okay, suppose here as you can see that is R join join I am writing here. Okay, R join S join T. Okay, if you change the order, that is suppose T join R and S. See here it is, the order has been just jumbled up. See the order here, the R join, this is in sequence, R join S within bracket S join T. Okay, equivalent to the P comes here and R inside the bracket. So it is just arbitrarily shuffled. that is T join R join S, but they are equivalent. If you can order in any order and you get the same result for those multiple relations which are specified in the query. Okay, now let's prove it. That is, suppose take this part, the left hand side, okay, LFH. So we know that for two relations, that is when we have only two relations, suppose you just forget about this R, you just think of S and T. For two relations we know that it is commutative and associative, right? So here it is take this part inside this bracket and just apply the commutativity of the two relations to get this, right? We can apply this commutativity to get this result. This is perfectly true for the commutative. Now for the associativity, obviously the three relations are involved, as you can see here. So considering this part, this equation, we can write that it is associative as R and T and S, right? We get using applying associativity here, we get this. This is equivalent to this, right? And this is equivalent to this, right? Now on this, forgetting about S, just take the commutativity of R and T. So we can change it, right? So we get T is equivalent by commutativity this way, right? This is equivalent to this way, and this remains the same, right? Now this part is same as this part, so hence this is same as this, right? So you get any suppling of any order, you can even prove by taking this part, and in the same way you can prove that this is equivalent to this one. Okay, that is, first you take commutativity and associativity interchangeably on those relations, and you get the result of the other part. But the main point is that you, in any order, if you write those three relations, they are equivalent to each other for joining and cross products. Okay. Now equivalence of those relational operations we have seen. So the next topic, let's move to enumeration of alternative plans. Okay. Once we know that those operations are alternative or the equivalent, let's have a look of the different type of alternative plans which the optimizer will consider for considering a particular plan. Okay. So while we go for those alternative plans, to identify the subset of the plans considered by the typical optimizer, there are two important cases to consider. Okay, what are those important cases? One is where in the from clause you have only one relation mentioned. Okay, so suppose a single relation is mentioned in the from clause, that is one kind of different case, because in that case you don't have a join operation to perform, right? You have only selection and projection, and obviously group by having clause and the aggregate operations to be performed there. So on the other hand, if you have two or more relations in the from clause, then obviously apart from those selection, projection and the aggregate operations group by having, you have to do the joining also, joining of those relations based on the join condition. Okay, and obviously when you have those number of plans in your hand for execution of either of these two, single relation query or the multiple relation query, you have to go for the plan which gives you the least estimated cost. Okay, the plan which gives you the least estimated cost, or you can say least number of IO operations to be performed. Okay, so for the single relation queries, as you know, in the from clause you have only one relation name mentioned, and obviously the other parts are same for both type of queries. Only thing is that in the from clause in a query you have only one relation mentioned for those queries. So these are the case of single relation queries. So let's take one example here. So select S rating and the counter from seller S where rating is greater than 5 and age is equal to 20, and the relation is grouped by the rating and having count distinct greater than 2. So you see here the relation name is only sellers. Okay. So for what this query is doing, for every such sellers who have rating greater than 5, see the condition mentioned here is in the where clause is the rating has to be greater than 5. So rating greater than 5 and the number of 20 years old sellers, you see as age is seller, as dot age is seller. So the seller has to be of 20 years age and seller has to have a rating number which is above 5. Okay, those kind of tuples will be first retrieved. Okay, and then provided there are at least 2 sellers with the different names. So this comes from this having clause. Okay, because this having clause considers the S name here. So and the distinct keyword is here. So there is the provided that there are 2 such sellers who have different names. Okay. So and it is grouped by the rating because you are trying to find out the rating which are above 5. Okay. So for those kind of sellers who are of age 20 and rating above 5, and there are at least 2 sellers in the group who have 2 distinct names, for those sellers you provide the rating, that is the projection of the ratings, and the counter, how many numbers are there. So how many numbers of such sellers are there. Okay. So that is what the query is doing. So first this query is converted into its relational algebra expression. Okay. So relational algebra expression is given by having distinct S name, the name of the seller, right, and then the that is what who at least there should be 2 sellers with the same distinct names, different names, and grouped by rating. It is ordered by rating. So different ratings are clubbed into different groups. Okay. So rating 5 will be together, rating 4 will be together, rating 3 will be together. That way it is ordered into different ratings. Okay. So then the projection of S rating and S name is done. Okay. Depending on the selection condition, selection operation, that is S rating is greater than 5 and the age is 20 from the seller. So this is in the where clause, this is the projection operations, and there is no joining condition or cross product because there is only one relation. Okay. So that is what it is done. Now relational algebra expression is found, right? Now to develop the plan. Okay. So once relational algebra expression is found, the optimizer will try to find out the best plan to execute this query. So it will consider all different kind of resources available in his hand. By resources I mean the different type of indexes available in his hand to identify which kind of evaluation plan will give it the least cost to execute the query. That is least amount of IO to execute the query. Okay. So suppose first let us go for the planning, that will be taken up by the optimizer, provided that there is no indexes available for any of the attributes mentioned in the selection clause, mentioned in the selection operations, that is the where clause. Okay. So if there is no attribute with index in this particular part, that is this actually S rating greater than 5 and age equal to 20 for this example. So age also does not have an index and rating also does not have an index, and you are trying to project rating on the results of this operation. Okay. So if there is no index available, then What you need to do, you have to scan the entire cellular relation, okay, then apply the selection and projection on that. So there is no alternative. You have to scan the entire relation that is stored in the backend, in the disk, by page, and perform the selection operations according to the selection operations conditions, and do the projection, okay, without duplicate elimination, of course, okay. So and then you have to do projection and selection has been done. Once those projection and selection of the scanned results or scanned tuples are done by this part, and then on the resulting tuple you can apply the group by clause according to, in this particular example it is group by rating. So group by will be done, that is on the retrieved tuple and the resultant tuple which are being retrieved according to the condition, okay. Then on that the group by will be done, and according to that the those groups which are not required will be eliminated, and those groups which are there, that is the only those groups actually, those different groups are actually clubbed into different parts, okay. So group by will be done, group by clause in the example query, and then the answer will be, and then according to the having clause, only those elements which meet those criteria, those will be taken into consideration according to the having clause, okay. So initially only selection and projection will be done according to the selection operation, okay, and then on the result that you get, the group by will be done according to the group by criteria. Here group by is rating, so according to the rating it will be the retrieved tuples will be arranged, okay. So you can have if there are 5 ratings, suppose rating 1 will have all the tuples which are retrieved by the selection operations there will be together for the rating 1, for rating 2 will be together, rating 3 will be together, it will be divided, okay, grouped together. And then from there the having clause will be applied on that, those to identify only those clause tuples which meets the condition in the having clause, okay. So that is how the plan for the execution of this query will be done if the indexes are not available. So remember that here the main difference is that if there is no index available, then there is no other way left out other than to go for the direct file scanning, okay. So it basically the query optimizer will go for scanning the files directly by retrieving the pages from the hard disk, okay. Now the cost of this approach involves the following steps. As you can see, the step number 1, perform that cost that is required to perform the file scan and apply the selection and projection. So that is the main cost, because you have to go for direct file scanning. So all the pages which are there in the back end for the in the database which relates to that particular that particular relation which is mentioned in that query, okay, all those tuples has to be retrieved by direct file scanning, and then apply the selection and projection on that. So that is the main cost involved there. After that, writing out the tuples of the selection and projection, because you have retrieved those, so you have to write down those tuples in a temporary relation, okay, and then sorting these tuples to implement the group by clause, okay, because see, to perform the group by, as we are discussing algorithms in the previous topic, there, to perform the group by, when you have hash indexing available, you can apply obviously hash index. Since in this particular case we have already specified that there is no index available, so there is only one criteria to perform the group by on the result is to do the sorting, okay. So you have to apply sort these tuples to implement the group by clause. That is the attribute which is mentioned in the group by. In this example, it is rating. So on the basis of rating, you have to do the sorting, okay, to implement the group by. Now, plans utilizing an index. If there is an index available, okay. So suppose if there are some indexes, let us call it indexes, that is maybe suppose there are some more than one index available, then what we will be doing here? That is, because indexes gives you a plan which for the query execution, which can give you many times faster execution of the query than a simple query execution. Since these databases for which we are discussing these algorithms are the large databases where there can be millions of data for the distributed database systems. So, or you can say for those distributed architectures, as I told you, this is basically this subject entirely is for the large databases, right? So where you have multiple multiple users are operating concurrently on the database. Okay. So here on this, to have a faster execution, the index is a very important thing to have in this kind of database. So you need to, the database administrator need to create different type of indexes for the database. Okay. So if for and see the indexes which are created by the database administrator, they do create the index based on their intuitions. How we talk about the intuitions? That is by predicting the load pattern of the that is the database load. That is the way the customer's behavior may be judged by the database administrator to create the database index, because the people doesn't know what kind of query that may come from the user's end. There may be different kind of queries that may come from the user end. Okay. So some queries, the most common queries indexes are created by the database, so that for those queries the database execution can be done faster. Okay. But there may be some queries, exceptional queries may be set, may be thrown by the users for which the indexes may not be available. Right. In that case, file scanning and the sorting were the only options available to do the execution. But if the indexes are available, then obviously we should go for using the indexes so that the execution becomes faster. So here, the single index access path, if suppose there is we have the indexes available for the attributes in the selection clause, in the selection operations. Okay, those attributes which are mentioned in the selection operations in the where clause. So if several indexes match the selection condition in the where clause. Okay, so there is a where clause operation mentioned, and you have more than one index available. So what the optimizer will do? It will go for all those different. Suppose by multiple indexes means, suppose a particular attribute is there for which you can apply B+3 index is also available, hash index is also available. So you may have to choose one of those indexes. Okay, so that may be so in that case, optimizer can choose the access path that it estimates will result in retrieving the fewest pages. Okay, so those selection conditions, selection operations on which the indexes are available are the primary selection terms. Okay, so those primary selection terms will be first identified, okay, on which the indexes are available, and depending on the type of suppose index available, suppose if there are more than one index available, the administrator will identify which will give the least number of pages retrieval from the backend. Okay, so depending on that, whichever gives the least number of pages retrieved from the backend, that is the optimized one. Okay, so that is basically that access path will be taken up by the optimizer. Okay, and then on the tuples which are retrieved using those primary selection conditions, primary you can say the selection terms. Okay, those primary selection terms, as I told you, primary selection terms means where the indexes are available. So tuples which are retrieved by those primary index terms, on those tuples the non-prime operations, that means where the indexes are not available, those non-primary selection terms are applied. Okay, and the final result is identified. Okay, first index is used. Whenever index is available, it goes for application of those or use of those indexes for selecting the tuples, retrieve the tuples. On that you apply the non-primary selection terms on that. Okay, and then we can go for proceed to the computing of the grouping and aggregation operation. Okay, so grouping and aggregation operations can be operated on those results after the primary selection terms and the non-primary selection terms are applied. Okay, so that is how the it is evaluated. A single relation is evaluated when there is a index available. Okay, so when there are index available, a single index available is there, we can do that. If there are multiple index access paths available, okay, multiple index access path is there, in that case, that means the several indexes are available, right? And those are basically the indexes which refers to the clause 2 and the clause 3 criteria. As you have, you know that those, clause 1 is the clustered index, clause 2 and clause 3 are the non-clustered index, where you apply the RIDs to retrieve the tuples, okay? So, in that case, what is need to be done is that you need to get the set of RIDs which matches those multiple access paths, okay, for those indexes which are in the clause 2 and clause 3. And provided that we assume that there are the RID representation includes the page numbers, so those page numbers of the RIDs are those pages are retrieved, okay. So, and then and retrieve the tuples that satisfy the primary selection terms of all the matching indexes, okay. After those all those pages are retrieved, you retrieve the tuples which actually meet the primary selection terms. Primary selection terms means on which you have those indexes, indexes which are actually unclustered indexes, which refers to the 2 and 3, alternative 2 and 3, okay. And then after that, those results, you have to perform the projection, and the non-prime selection terms can be applied on that result, okay, followed by the grouping and the attribute. So, what is done here in this case, multiple index access path, is basically we are referring to the unclustered index part, okay, where RIDs are retrieved first. Corresponding to RIDs, assuming that RID also includes the page number, we will retrieve those pages where those tuples are available, okay. After that, we will basically have apply the primary selection terms, because we are talking about primary selection terms because we are talking about index here. So, apply the primary selection terms for all those matching indexes. Only those tuples from those pages are taken where it matches the RIDs, right? So, those tuples are taken out and then project according to the project condition, that is the select clause operations, the projection is done, okay, and the non-prime selection terms are applied on that, okay. Only after that you go for the grouping and the aggregate operation on the result, okay, for final tuples which are to be taken into consideration, okay. So, there is another way of applying that is the generating a plan, a special case you can see, sorted index access path, okay. Suppose there is a group by clause in the query, and the attributes which is mentioned in the group by, like in this particular example, the query that we have considered, group by is done on the rating, seller's rating, right. So, suppose for that rating attribute, there is a index available, okay. So, there is a index available for the rating. So, what you can take advantage of the index to, and of course, if we have that, suppose that particular attribute as a prefix of some tree index, okay. So, we know that in the B plus tree, you have the leaf pages are always ordered, they are always sorted, right. Suppose that is why it has to be tree index. So, if suppose that particular attribute which is specified in a group by is the prefix of some tree index, then you can take advantage of that tree index, okay, to select it first. Instead of going for selection operations in a where clause or the projection operations, you are just directly going for the group by attribute to take advantage of that, okay. So, you identify those attributes, you just those tuples first using the group by attribute by taking advantage of the B plus tree, because you get already the sorted order, okay. and then all selection conditions are applied after that on those retrieved tuple. Okay. Since you have already done group by, you have sorting has been already done because of the B plus tree, the sorted of tuples you have retrieved, and then you can apply the selection conditions on that, okay, on the each retrieved tuple, and unwanted fields can be removed from there, okay, and then the aggregate operations can be completed on the each group, okay. Actually, this strategy is well suited for the clustered indexing only, okay, for the not for the unclustered indexing. Unclustered indexing suits this particular technique very well. Then index on the access path is another way of taking advantage of the index for the alternative plan. Suppose if you, for those attributes mentioned in the query, in the select, all the attributes which are mentioned or in the query, that is in the select clause, that means the project operations. For the where clause, selection operations, and group by and having clause, whatever is there mentioned there, because it is a single relation query, so there is no from clause, okay. So here, if all those attributes which are mentioned in the query are included in the search key of some dense index, okay, they are all included in the search key of the dense index, then you don't have to go for retrieving tuples from the pages directly, but that is, you don't have to do any file scanning there, not from the retrieving tuples from the pages of the relations. You can directly take advantage of the indexes to execute the query. That is, if all the attributes of this part, select, where, group by, having are part actually of the dense index available with you, then you can take advantage of the index to execute the query, to execute the plan. That is, this plan is the best one for those type of queries. Okay. So index on the access path is a plan to be considered only when all the indexes are available. All the attributes are available as index in the index file. Okay. So this is all about the alternative plans, enumeration of alternative plans when there is the indexes are available, or if there is no index available, okay, the plan that is to be taken by the optimizer is discussed. Okay. So in the next class again we are going to discuss the multiple relations, where the alternative plan which are to be considered for the multiple relations. Okay. So thank you.